geobyte.
Dear students, now let us discuss the previous year questions for the very important unit and also very easy unit, that is motion in two dimensions. Okay, I hope all of you clearly understood all the theory concepts what we discussed for motion in two dimensions. Understood or not? Yes, then let us take the very first question. Look at the question. It is asking like this. A projectile is projected with a velocity of 40 meter per second at an angle theta with the horizontal. It is given that initial velocity initial velocity u is given 40 meter per second, and the projectile is making an angle theta with respect to horizontal. If r is the horizontal range covered by a projectile, and after t seconds its inclination with the horizontal becomes zero. You know, only at the topmost point it is having only horizontal component of velocity, vertical component of velocity zero for the projectile motion at the topmost point. At that topmost point, as you know, the projectile is making zero angle with the horizontal. Okay, so for that it is given the time taken is t. Okay, then the value of cot theta, you're asked to decide what is the value of cot theta when g equal to 10 meter per second square. That is the question given. For that, let us take the projectile motion. Look at the look at the projectile is moving in this particular direction with a velocity u, is making an angle theta with respect to horizontal. As you know, if any object is making an angle theta with respect to horizontal, it is developing two component of velocities. Horizontal component of velocity u cos theta, and this is the vertical component of velocity u sin theta. Okay, then by the time the projectile is projecting, it is reached to the topmost point. This is the topmost point. This is the topmost point where the, let me write it clearly, that is the topmost point. At the topmost point, this is the topmost point. At the topmost point, it is having only horizontal component of velocity. It is having only horizontal component of velocity u cos theta, means vertical component of velocity 0. At that point, the projectile is making zero angle. At this point, projectile makes zero inclination, zero inclination, zero inclination with the horizontal. Okay. For reaching to that point, it is clearly given that the time required is t. The time required is t. Okay. Then at that height, at that point, the projectile is covering the maximum height. Max height. Then the time to reach the maximum height is time of ascent. Time to come down from the highest point to ground level is called time of descent. The time of ascent plus time of descent equal to time of flight. By the time it is flying with the time period t, right? 2t, actually 2t. It is given small t is for time of ascent. It is covering the horizontal distance r called range. This r is the range. Okay. Now as we know, the time of ascent t equal to u sin theta by g, right? This is the formula. From this I can write that initial velocity u equal to tg by sin theta. Tg by sin theta. Then what is the horizontal range? Horizontal range R equal to horizontal component velocity into the time of flight. Time of flight equal to 2 times the time of ascent, because time of ascent equal time of descent. Right, from this I can write that R equal to, look at the U value. U is Tg by sin theta into cos theta into 2t. Range equal to, here it can be written as 2t square g into cos theta by sin theta. Okay. What is the cos theta by sin theta? Cot theta. Cot theta equal to cos theta by sin theta. Mathematics, simple mathematics. From this R equal to 2t square g into cot theta. From this, right, cot theta equal to range by 2t square g. Okay, it is equal to range by 2 into g value given 10 into t square. Simplify this value for getting r by 20 t square. That is the cot theta. R by 20 t square. Look at the options. R by 20 t square. Option A is absolutely correct. Understood clearly? I try to explain each and every point at your understanding level. Okay? Shall I take the next question? Yes. Look at the next problem. Try to read it clearly. It is asking like this. A rigid body rotates about a fixed axis with variable angular velocity equal to alpha minus beta. It is given angular, right, velocity omega equal to alpha minus beta t given at the time t, where alpha and beta are constants. Given alpha and beta are constants. The angle through which it rotates before it is stopping. What is the angle rotating by the rigid body before it is stopping? That means final angular velocity equal to 0. To have the final angular velocity 0, what is the time required? That is the question. For that, as you know, one of the equations of motion for angular motion, right? Omega equal to omega naught minus alpha, actually plus alpha t, one of the equations of motion, right? Alpha t, let me write it clearly. It is alpha t, alpha t. Now compare these two equations. This is the one, this is the two. Then I can say that this omega naught must be equal to alpha, and this alpha equal to minus beta. Alpha equal to minus beta. Okay. Then another equation of motion for angular motion is, right, omega square equal to omega naught square, right, plus 2 alpha theta. Okay, but it is given what is the angle made by the rigid body by the time it is brought to zero speed, right, before it is coming to rest, means omega equal to 0, then 0 equal to omega naught. Look at the omega naught, alpha square, right, plus 2 into alpha equal to minus beta into theta. From this I can write that 2 beta theta equal to alpha square. From this, angle made by the rigid body equal to alpha square by 2 beta. That is the answer. Look at the option A. Option A is absolutely correct. Okay, are you following clearly? Yes. Similarly, let us take the another important problem. Look at this problem. It is asking like this. The range of projectile projected at an angle of 15 degrees with the horizontal is 50 meters. That means if angle of projection theta 1 equal to 15 degrees, the horizontal range R1, let it be 50 meters. That is the condition. If the projectile is projected with same velocity at angular at an angle of 45 degrees with the horizontal, then its range is. That means if angle of inclination theta 2 equal to 45 degrees, what will be the range? R2 equal to how much? That is the question. Okay. This is the case 1. Case 1. This is the case 2. This is the case 2. For the first case, theta is 15 degrees, range is 50 meters. Right? For that, look at the arrangement. Look at the what uh, projectile projectile is making an angle theta with respect to horizontal. He is maintaining the right u velocity. It is developing two component velocities. This is the u cos theta. This is the vertical component velocity u sin theta, and this is the horizontal range r. When theta 1 equal to 15 degrees, range is given 50 meters. Okay, 50 meters. From this, as you know, range r equal to, let us write the formula for range. Range r equal to, right, range r equal to what? U square sine 2 theta by g. Okay. Then r1 equal to, I can say r1 equal to, r1 equal to u square by g into sine 2 theta 1. The theta 1 is 15 degrees. Range r1 given 50 meters, u square by g into sine, since theta 1 is 15 degrees, 2 theta 1 is 30 degrees. Sine 30 equal to 1 by 2. From this I can write that 50 equal to u square by g into 1 by 2. 1 by 2 because sine 30 equal to 1 by 2. From this I can write that u square by g equal to 50 into 2, 100. 100. Then look at the second case. If theta 2 is what 45 degrees, is it correct? If theta 2 is 45 degrees, let me write it clearly. If theta 2 is 45 degrees, what is the range? Then r2 I can say r2 equal to again u square by g, u square by g, u square by g into sine 2 theta 2. So R2 you need to find R2 equal to u square by g, already got it, 100 into sine 2 into theta to 45 degrees, that is 90. Sine 90 is how much? 1. Therefore R2 equal to 100 meters because sine 90 equal to 1. Okay, let me write it. Sine 90 degrees equal to 1. So R2 equal to 100 meters. Look at the options. Look at the options. Option C is absolutely correct. Understood clearly? Yes.
Geobyte.